Okay, guys, this is geotrig outline lesson 9. We're going to talk about congruent figures today. So what does it mean to be congruent? It means when two figures are geometrically
Similar.
Identical. Guys, that means that everything about them is exactly the same. Notice that we have a couple of examples that are congruent. When we talk about line segments, if they are congruent, it doesn't matter which way they are positioned. If they have a length of 2, the line segments are geometrically congruent, or identical, which means they are congruent. When two angles have the same exact angle measure, we say they are congruent. When two triangles have all their sides the same and corresponding angles the same, we say the two triangles are congruent. Okay? And we're going to go over a lot about triangle congruency and how you can prove triangles to be congruent or triangles not to be congruent. There are some that work and there are some that don't work. So be very, very mindful of it. May I turn the page? So, how can I know if something is congruent or not? Is I can pick one of the figures up mentally guys, in my head. I can flip it, I can turn it as necessary, and place it back on top of the other. Going back, could I take this line segment and turn it 90 degrees and place it right on top? Yeah. Would you even notice there were 2 of them? No. That's what makes them identical or congruent, okay? In every aspect. Now, what does similarity mean again? Similarity. Sameness. Okay, I like that. I don't know if that's the correct spelling, but sameness or likeness, right? Which means they look like each other, but they are different sizes. That's kind of like going back to Austin Powers and looking at Dr. Evil and Mini-Me. Oh, that's a little for you guys? Okay, so you got Mini-Me. So they're identical, but everything's proportionally sized. Okay? Remember, they have a scale factor between the two. But here's the cool thing, guys. We talked about, I think it was on Friday, we talked about congruency and how it can mean something, but something else doesn't mean it back. But congruency, guys, is similarity. To be congruent, they have to look alike. Makes sense. But here's the cool thing. They have a scale factor of 1. That means there's a 1-to-1 correspondence. So if one side's a value of 2 has a length of 2, there's another side in the other triangle or the other object that has a side of 2. And so on, down to the angles and everything else that make it up. So that means this line right here. Congruency implies similarity. But just because they're similar does not imply they are congruent. I'm not exactly sure what those little squares should be.
The little arrows, yeah.
They're little arrows?
Emojis on here.
You just go to insert.
Because there's a nice little...
Yeah, there's insert. They're little things. I thought they were for sure come up on here. But it's a one-way street here as a fact that if it's congruent, it also is similar. But similarity does not mean congruency because they could be a different size. They have a different scale factor. Okay? Then we're going to go into the definition. What's a postulate? I'm going to give you an example of a postulate. Real-life postulate here. Mr. Konchak's cool.
Wait, so that means the opposite? Invalid.
How about a postulate, guys, is something we just accept as true without proof. So of course, Mr. Contract's cool. So we say that it's assumed true without proof. I mean, we could sit down and prove every single thing we're going to talk about in this class, but if you guys want to actually be able to get through and actually figure out why we're proving these things, because we need to use these ones, we're going to use postulates to prove everything else. So we're basically going to step back and say these are the ones that we're going to assume to be true without a proof, so we can prove everything else based off of them. But that also means, guys, that if I can come back and pull that postulate out and say that wasn't true, then everything else would not be true. There are 10 postulates that all of your math that you guys know is based off of. All of it. Euclid came up. I think it's Euclid. You know, yeah, Euclid. I think it's Euclid. It's in one of the lessons. But basically, what's the distance? What's the shortest distance between 2 points?
Straight line.
It's a straight line. That's one of them. But guess what? We're on Earth. What's really the shortest distance from here to Los Angeles? It's a straight line, but is it really straight? Because if I took a straight path to Los Angeles, I'd probably have to go through a couple...
Well, you could fly.
No, still, flying is... Okay, flying would probably be your best option, right?
Uh-huh.
That's the straightest line than driving. But still, the Earth is round. You have to go around the curvature.
Yeah, you have to go, yeah.
There's something called non-Euclidean math. I had to take that in college, where you actually will find that arc. So it's weird. It's mind-blowing. The fact that there's so many different types of math out there. But the stuff that you guys are dealing with, deal with 10 different postulates that if you assume are true, then all the rest of it works. You take one of them away, it all falls. We'll get to that in one of our lessons. But a postulate, guys, again, you just assume, let's go with it. Like Mr. Konchak's cool. What are some of these, guys? Some of these postulates are dealing with triangle congruency. We have SSS, side angles, SAS, ASA, AAAS, HL, and we have one called the donkey postulate. One of the letters combinations that we don't see up there. So, what do you think SSS stands for? Side, side, side. If I have, guys, two triangles. We got triangle A, we got triangle B. And that's a bad B. My B. Okay. If I have these two triangles and I want to prove that they are congruent, if I went back and I said these sides correspond with those three sides, how many different triangles can you make with the exact same sides? One. Therefore, if they have all the same sides, there's only one way to connect them all, whether I rotate it, flip it, or whatever. It has to create the exact same triangle. So therefore, they are congruent. Same thing. Angles will follow one L along. The next one is SAS. What do you think that one is? Side angle side. Side angle side. And if I had this one, which means a side and a side, it means an angle and another side. The only way this works is if the angle that you have that's congruent is between the two sides that you know are congruent. Okay? And of course, ASA would be angle, side, angle, which means the side that's congruent has to be between two angles that are congruent. So if I had to draw out triangles here, I'd have an angle and an angle. I would go back and say a side and then another angle. Notice I'm using different tick marks to denote different things are congruent. Yes? And notice that our side that's the same is between the two angles that are the same. It wouldn't work any other way. Now guys, we also call this one the angle, angle, angle side. So if you want, I could write that out for you. Angle, 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 side. Guys, that's the same exact setup. It's just that they have the third angle in there. Why would that be the same? Why is this okay? Why is this the same? Why is it the same as angle, side, angle?
Because
What do we know about angles?
it's the same thing.
Okay. What do we know about the angles of a triangle? If you know two, you know all three. So therefore, if I am not given all three, then I'll just use angle, side, angle. But if all three are there plus a side, then I'll probably default to angle, 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 side. Or I might not even care. I'll still use angle, side, angle. One less letter to write, a little bit easier. Does it kind of make sense? And then we have HL. Ooh, HL. Ooh, close. Hypotenuse. Leg. Now, hypotenuse leg, guys, only works for a special triangle. It only works if it happens to be a right triangles. So hypotenuse legs only works for right triangles, and it says that if the hypotenuse or hypoteni are the same, and one of the legs, I don't care which one you call it, it works. Because obviously, at this point, if it's a right triangle and you know a hypotenuse and a leg, you could find the third leg. And so therefore, or the second leg, or the other leg of the, or the other base, and those would end up being the same. You could use the Pythagorean theorem to solve for that third part, right? And then there's something called the donkey postulate. What do you think it is? I'll say the words. Angle, side, side. But if I wanted to abbreviate that, what would it be? It'd be ASS. Oh my, I'm recording this, guys. Now, here's the thing. There is, guys, no donkey postulate. The donkey postulate does not work. The donkey postulate, which so many students want to use to prove triangle congruency, just doesn't work. There's not enough information to show that two triangles are congruent. So therefore, I do not want to see the donkey postulate because we're not technically allowed to say that or use that here, so therefore, not going to.
Cancel it.
So, what we're going to do with these postulates, guys, is proofs. And we're going to use that deductive reasoning. What do you think we made those little syllogisms up of, if it rains, I'll go to town. It's raining, so therefore I go to town, right? Logical or valid or invalid arguments. So we're going to use deductive reasoning, geometric proofs, systematically, lead a reader step by step from the premises of a proof to a conclusion. What may have been suspected, hypothesized, but wasn't known for sure. A proof, guys, is going to say, hey, take this information and prove to me that this is true. I'm basically telling you when they do that, there's a way to make it happen. And so what you need to do then is do a single step and then give a reason of why you can say it. It says, in proofs, one must back up everything they say and do with a reason, because I said so. That was a joke, guys. Okay. Here's the thing. Guys, go back, go home, and try arguing with your parents of why you want to do something or not want to do something, and just say, because I said so. I don't know if it's going to fly. It does work the other way, but not your way. Never works in your favor. It'll never work in your favor. So, when we write statements of triangle similarity, listen, John, or triangle congruency, we must be careful to list vertices in the correct order so that our angles at all the vertices are corresponding angles. Remember the statements of similarity? We now can use the same idea for statements of congruency. The next slide is going to show that. Okay. Is this symbol here? And you guys can't see it from back here, but it's on your printout. I'll make it a little bit larger here. It's the similarity symbol on top of an equal sign. So, if you saw this statement, guys, it'd be called, or you would say it as, line segment AB is congruent to line segment CD. Now, we also could go as far as saying triangle ABC is congruent to triangle DEF. The coolest thing about this, guys, is that just like before when we said statements of similarity, I know that AB is congruent to DE. I just know that by that statement alone. So yes, it's very important that you list it correctly. I can't stress that enough. You can't make your own stuff up here. This stuff needs to follow from the work you are doing. And just like I can say BC is congruent to EF, or AC is congruent to DF. You see in those three positions there. I can also say angle A is congruent to angle D, because those are your vertices, these are your endpoints of your triangle. We also should see that we are going to write proofs. And those proofs, guys, follow this format. They follow the format that says, I'm going to have a statement, and I'm going to have a reason. So in step 1, I'm going to state something. And then I'm going to say why. Then I go to step 2, why. Step 3, why. Generally, almost 99.999% of the time, you will always put anything that you're given. So it's going to tell you this triangle and this triangle have vertical angles in them or something. And so you write that here, and then the reason? Given. And your last line, whether it's 3 steps or 25, your last step will be the show me, the proof. Triangle ABC is congruent to triangle DEF. Why? Side, angle, side. And then you have to put all the work in between of showing all of that information. There. We'll get there. We're going to do a problem. Okay? So, first problem up. Given line segment AD is congruent to line segment AD. And line segment DC upside down T is line segment AB. What? What does that mean? What does that thing mean right there? Certain type of angle. Perpendicular. So that means that line segment DC is perpendicular to AB. Wait a minute. I left something off this graph. That's D. So make sure to put that on, please. So what we need to do is we need to construct a 2-column proof that takes my given and takes me on a journey to get to the point where I can officially say that line segment AC is congruent to line segment BC. Are you ready? First thing I should always say that you should do is on your paper, redraw anything they give you. Because that way you can mark on it. Number 2, I want you to make a 2 columns. The first column, you put statement. And the next one is reason. Statement number 1, guys. This is about one of the only times you will be able to do 2 things at once. I want you to put all of the given. AD is congruent to BD. DC is perpendicular to AB. And the reason for number 1 is they told me so. Right? We say given. That was the stuff they gave to us. Your last step, guys, which is going to be way at the bottom somewhere, will be AC is congruent to BC. And the reason, we have to figure it out yet. It very well could be a 2-step proof, it could be a 3-step proof, or it could be a 20-step proof. We don't know until we start working with it. Okay? So, step number 2, or statement 2. Well, maybe before we get to statement 2, we should take our given and superimpose it onto our diagram. AD is the same as BD. Where is AD? That's here and here, right? Those are congruent. We also know that DC and AB are perpendicular, aka form what?
DCAB.
What kind of angles are formed at perpendicular right angles? So, I could say this, right? But here's the thing. I had to pull that from memory. So, let's state it. Angle. I don't think I can just say angle D. Because there's angle 90? No. If I have to name an angle in a certain spot, I have to use 3 endpoints. What 3 endpoints will I use then? A, D, C. And I'm going to say angle B, D, C. It's an angle. It's an open, like a less than symbol. Okay. R 90 degrees. Is that what we're saying? Or right? Or right, I guess. Matters how you want to look at it. It's enough for everybody to walk. Someone who walks in the room can say, "Oh, I made those right because," or not put a little box in there because they're both right because of the definition of what? Perpendicular lines. Definition of perpendicular lines. Definitions, guys, you just use them. It's because it's a definition of something. If it tells you there's an equilateral triangle, that means all the angles are 60 because of the definition of an equilateral triangle. Right? Stuff like that. Next is 3. Notice that I did not put 3's answer or reason here. I'm going to keep everything in a nice, neat row. You row a boat across, right? That's how you row boats. It goes down in columns here. Columns hold up buildings. They go up and down. Rowing goes across. So, I know AD is congruent to BD. I know I have right angles. Young?
What the?
And. What else do we have? You may have to find something, guys. Just gonna give it to you. Find it. You have to search. Because that's the whole point of these proofs. They're not just giving you everything. There's this step, and then we can finally two more. Actually, there's 3 steps left, including this one. I think on this one, yes. They're triangles, right? Audrey, what are you saying? Yeah, CD, guys, what do? They share CD. So, how do I say that? CD is congruent to CD. Well, that should make sense, doesn't it? Do I really have to state that so that I can go like this? Yes. If something is congruent to itself, you have to state it. Does anybody happen to know why? There's a name for this. When something is the same as itself. Most of us did this morning. We looked into a mirror and we saw our reflection. So, this is called the reflexive property. The reflexive property, guys, says that basically something is the same as itself. What can I say? Step number 4. We're getting close. This is one, and there's one more. The last step is going to be 5. And that is just going to say that AC is congruent to BC. But what's 4? I'm going to go back. It's one of those. Which one? No, donkey posse doesn't work. We talked about that. What do we have? Side angle side, guys. I have sides and I have an angle between them that's the same. So, the reason, guys, is going to be side angle side. But what are those? Those postulates, guys, is for triangle congruency. Your statement now has to be the 2 triangles being congruent. What's the first triangle? ADC is congruent to. Now you have to purposefully list the order in the next triangle the exact same way. So, the way I like to look at this is, we started with A. A is opposite the, or opens to the double. Double goes back to B. So we know it's B. Then we went to D. D was the 90. D is the 90 again. And the only thing left is C. That is the proper triangle congruency statement. Which is by side angle side. Wait a minute. So what does that mean? That means that this triangle on the left is the exact same thing as a triangle on the right. That's the only way they can be congruent. We just proved they're congruent. If I said you're the exact same as someone else, what does that mean? That everything about you is the same, right? Look where A, C, and B, C are. So what does he mean about those 2 sides? They have to be the same. That's why I'm stating it down below here. But there's a special reason for that. It's a fun one. It's called corresponding. Hold on. Its corresponding parts of congruent triangles are congruent. That means if we're congruent, all the corresponding pieces in the right places also have to be the same. Yes? Nobody wants to write that every single time, do they? So, here's a better, shorter way. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Remember that. Homework, lesson 9, page 71. 1 through 5, 9, and 20. Have a great day.